My dear students, yesterday we have seen the examples on the binomial distribution with the relevant formula. Let me consider in continuation of the same, we shall go for solving the examples on the Poisson distribution also. Before going to solve any example, one thing is to note that keep the formulae for mean and standard deviation of both binomial and Poisson distribution with you. Write the formula on the page, on the top of the page, so that you can check which distribution we need to apply from those two above formulae. Do not get any confusion here, because in the examination the word binomial or Poisson may not be given. By observing the nature of the example only, we need to decide which distribution we need to apply, whether it is a binomial or Poisson distribution. Okay, my dear students, let me continue the example. One example will be the number of accidents per day, that is X, as recorded in a textile industry over a period of 400 days is given. Fit a Poisson distribution. Refer here, the word Poisson is given. It's a very simple one. Simple example. Fit a Poisson distribution for the data and calculate the theoretical frequencies. The table is shown here. Okay, by the from the Poisson distribution we have mean mu. What is mean here? Summation fx divided by summation f. Therefore, summation fx is what? 0 into 173 plus 1 into 168 plus 2 into 37 plus 3 into 18 plus 4 into 3 plus 5 into 1 divided by summation f. Summation of all the terms given in the second row, that is 400. The calculation will be from your calculator 0.7825. Next, the Poisson distribution is given by P of x is equal to, this is the very important formula for any Poisson distribution, and P of x equal to what? M to the power x e to the power minus m divided by x factorial. That is, what is f of x here? F of x equal to 400 into P of x. What is the condition? Fit a Poisson distribution for the data and calculate the theoretical frequencies. The theoretical frequencies are given here. Therefore, we need to get 400 into P of x, because the condition is given what? Textile industry over a period of 400 days. Therefore, it is 400 into P of x. P of x is already given here. M is equal to what? 0.7825 into x e to the power minus m 0.7825 divided by x factorial. Okay, therefore f of x equal to, the simplified term will be 182.9 into 0.7825 to the power x divided by x factorial. Now we need to go for our calculating theoretical frequencies, and these calculating theoretical frequencies are got by from the table x equal to 0, 1, 2, 3, 4, 5. Therefore f of 0 is what? Putting x equal to 0 in this expression, 182.9 into 0.7825 to the power 0 divided by 0 factorial. The corrected value will be almost 183. Similarly, f of 1 will be 143, f of 2 will be 56, and f of 3 will be 15, f of 4 will be 3, f of 5 will be 0. Writing all the things at the end, the theoretical frequencies are from f of 0 to f of 5. They are given by 183, 143, 56, 15 and 3, and at the end 0. Okay, the example is over. Now come to the another important example taken from the old question paper. I will read the example first. In a certain factory turning out razor blades, there is a small probability of 1 upon 500 for any blade to be defective. The blades are supplied in a packets of 10. Use Poisson distribution to calculate the approximate number of packets containing, the conditions are given here, no defective, 1 defective, 2 defective blades in a consignment of 10,000 packets. My dear students, please refer this as a very important example. This example may not be given directly in the examination, but this type of example, the tune of the example will be very important. I mean, tune means what? The nature. Okay, yes. Come to the solution. P is equal to probability of a defective blade, that is 1 upon 500 equal to 0.002. It is already given. In a packet of 10, the mean number of defective blades is M is equal to NP. that is 10 into 0.002. It is already given, that is 0.02. 10. Why it is 10? In a packet of 10, the condition is given here already. The blades are supplied in a packet of 10. That's why it is 10 into P. Next, the Poisson distribution is already shown. P of x equal to m to the power x e to the power minus m divided by x factorial, putting the respective values, and f of x equal to what? At the end, in a consignment of 10,000 into P of x. Also we have e to the power minus 0.02 will be approximately 0.9802. Therefore f of x is shown here. Now come to our condition. No defective. No defective means what? X equal to 0. Put x equal to 0 in this expression. Therefore it is 0.9802. Next condition is one defective. One defective means what? F of 1. It will be almost 196. The corrected value. Almost means what? Corrected value. Next, two defectives, that is f of 2 is equal to 2. Okay, all the three conditions are given. Refer this example as a very important. The tune of the example, the nature of the example, the working condition of the example is very important. Try to know the procedure behind this example, not only this example. Do not go for any behalting here. It is not necessary also, it is not useful also. Okay, next come to the another example. The number of accidents in a year to taxi drivers in a city follows a Poisson distribution with mean 3. The word Poisson is already shown. Out of 10,000 taxi drivers, find approximately the number of drivers with no accident in a year, more than 3 accidents in a year. Therefore, by the data, mean is given by 3, and we have for the Poisson distribution, mu is equal to, that is, we can note it by m also, because m is given in the formula of Poisson distribution. Refer here. That's why mu is given by m also. That is 3 in this example. The Poisson distribution is shown here. Therefore, f of x equal to what? 1000 into p of x. Why it is 1000? It is already given. Out of 1000 taxi drivers, find approximately the number of drivers with these two conditions. Okay, therefore number of drivers with no accident in a year, that is f of 0 is equal to 50. Next, probability of more than 3 accidents in a year. Refer this condition in this example. That is why I chosen this example. More than 3 accidents, that is 1 minus p of x is less than or is equal to 3. You can put a question, sir, why you are taking 1 minus of this term? Because what is the probability condition? Probability of happening and non-happening is always equal to 1. 1 minus p of happening means what? It is not happening. What is the condition given? Find approximately the number of drivers with no accident in a year, more than 3 accidents in a year. Approximately the number of drivers with. Okay, therefore it is given by more than 3 accidents in a year means 1 minus p of x is less than or is equal to 3. Refer this condition. Therefore less than or is equal to 3 means what? P of 0 plus p of 1 plus p of 2 plus p of 3. P of x is already given in this one. Therefore put x equal to 0, 1, 2 and 3, and the simplification will be 0.35. Therefore, the number of drivers out of 1000 with more than 3 accidents in a year will be 1000 into 0.35, that is 350. Why? You can put a question, why we are taking this type of condition? Because what is the happening condition? It is the happening of the accident. And again, happening of the accident is not in a fraction or decimal form. It should be always what here? It's a real one, whole number. That's why it is. And again the condition is given out of 1000. Therefore 1000 into more than 3 accidents in a year, 0.35 is equal to what? 350. Yes, next come to another important example. 2% fuses manufactured by a firm are found to be defective. Find the probability that a box containing 200 fuses contains no defective fuses, 3 or more defective fuses. This example is as same as the previous example. Because this example is taken from the old question paper, that's why I have chosen this one. Again, P is equal to probability of a defective fuse. It will be 2 upon 100 equal to 0.02. Therefore, mean number of defective equal to mean NP is equal to 200 into 0.02. Again, observe here, mean number of, not mean number of defectives is equal to 200 into 0.02. That what is 0.02? The probability of defective fuse is already shown here. The multiplication will be 4. Therefore, the Poisson distribution is given by, again rewriting the formula, P of x equal to 4 to the power x e to the power minus 4 divided by x factorial. Therefore, the probability of no defective fuse, non defective piece what? Means what? X equal to 0. You put x equal to 0 here, therefore it is 0.0183. Next, probability of 3 or more defective fuses. Again, this is as like as the previous example. Here, previous example, what is the condition? Probability of more than 3 accidents in a year. Here, probability of 3 or more defective fuses. Both the conditions are same, but given the example is some different manner. Therefore, 1 minus of p of 0 plus p of 1 plus p of 2 into e to the power minus 4. Writing the formula. Therefore, here it is e to the power minus 3. Therefore, e to the power minus 3, substituting the respective values, p of 0, p of 1, p of 2. Therefore, the simplification will be 0.7621. This example is as like as the previous one. Next, another example. If the probability of a bad reaction from a certain injection is 0.001, determine the chance that out of 2000 individuals, more than 2 will get a bad reaction. I choose this example in view of present corona situation. Okay. Therefore, the probability of occurrence, that is the bad reaction, is very small. This follows Poisson distribution. One more reason to choose this example is what? In the example, there is no condition that Poisson is shown. Refer this example, read the example once again. Because you can put a question, why we need to use this Poisson distribution here instead of binomial? Or why, how it is possible to choose which distribution we want to use while solving the example. The reason is, I am repeating, as the probability of occurrence, that is a bad reaction, the condition is given, is very small. Again, observe here. This follows the Poisson distribution and we have by the formula. Therefore, mean mu is given by 2000 into 0.001, that is 2. Because how it is, it's already given. If the probability of a bad reaction from a certain injection is 0.001. and out of 2000, therefore mean number will be 2000 into 0.001. It is shown here. Therefore, now we need to get p of x is greater than 2. Why is p of x is greater than 2? The condition is given, more than 2 will get a bad reaction. Therefore, p of x is greater than 2. Refer the question at the end. Therefore, p of x is greater than 2. How it is possible to write 1 minus of p is less than or is equal to 2? Because how it is, the sum of these two will be what? Always equal to 1. Therefore, p of x is, again observe here, in the left side it is strictly greater than 2. In the right side it is p of x is less than or is equal to 2. Refer this condition. One condition I want to give here. Suppose in the right side if it is p of x is less than or less than 2, then what is the right side? It will be 1 minus p of x is greater than or is equal to 2. Either of the side shall contain less than or is equal to, or greater than or is equal to. I am taking in the right side because the left side is strictly greater than 2. Therefore, x is less than or is equal to 2 means what? X equal to 0, p of 0, p of 1, p of 2. Therefore, again writing the formula as you see in the previous example, the simplification will be 0.3233. 0.3233. My dear students, observe, write the formula. I am repeating the condition. Write the formula of mean and standard deviation of both binomial and Poisson distribution. Then go to solve the examples. And I have covered almost all the examples which are in a different manner, taken from even the old question paper also. Next we shall go for another two distribution which are known by exponential and normal distribution. Thank you.